laser beams to achieve incredibly high storage speeds. The information is inscribed in the crystal using two interacting laser beams. The material will store the data for a long time to come.
It's like fixing a photograph after it's been developed. You can fix the data there, and then it will keep for a very, very long time. Many of my colleagues have already tested that under very tough conditions, and they've found that the data would be stable for at least 1,000 years in a storage medium like this once it's fixed.
The basic principle of the optical data storage method is quite simple. Laser light is split into two beams. The information to be stored is encoded in one of the beams. Then the two beams are allowed to interfere in the interior of the crystal, creating a hologram. It contains all the information carried by the laser beam. The method can be used to store analog images as well as digital pictures in the form of dot patterns. But so far it is extremely expensive to produce the storage crystals, and that has made the technique hard to commercialize. However, Dentz is optimistic.
Both holography and information processing, or storage with light, are the future. A lot more can be done with light than we're doing at the moment. Light can carry information far better than electrons currently do, and that's going to be the future.
Holographic crystals are easy to handle. They have a huge capacity and are as durable as stone. And they will likely soon mark the start of a glowing future for optical data storage methods.
Restoring artworks to their original glow and preventing them from deteriorating in the future is an important cultural project. Light, temperature fluctuations, and humidity are extremely detrimental to these masterpieces. But the days when restoring a painting meant sitting down with a brush and some oils are long gone. Today, the field is just as high-tech as any other.
At the Altes Museum in Berlin, conservators are unpacking some of the treasures. The vases, weapons, tools, jewelry, and sculptures come from 4 continents, and some of them are 4,000 years old. The objects are all examples of the art of modern restoration that was showcased in a recent exhibition.
You can follow the entire history of an object, from its excavation to the restoration that was carried out 100 years ago, and on to today's restoration, which is mainly done nowadays in collaboration with scientists. We're getting new insights into which materials can be used for restoration, and the results are also exciting for the scientists.
Conservator Toralf Gopsch prepared the elephant woman for the exhibition, a figure from a Buddhist cult that once lived in northern China. Made of clay and straw, the 1,400-year-old piece took Gopsch 2 years to restore. In his workshop in the Museum of Asian Art in Berlin, the conservator collects all the data he can about the piece. That includes the site where it was found, a sandstone cave on the Silk Road. In 1906, the German archaeologist Albert Grünwedel explored the Buddhist temple complex where he found the ruined clay figure. After more than 1,000 years in the dry desert air, the elephant woman came to Berlin and underwent repairs. But the history of that restoration is full of gaps. What changes were made to the statue? What materials did the 20th century restorers use?
These are things we have to deal with today. We have to study the methods and substances the restorers used back then, because unfortunately these things weren't so well documented in the past.
Sounds like a case for the Röntgen Research Laboratory. Scientists here have been battling the ravages of time in artworks since the lab was founded in 1888. Conservator Regina Pausewijn is studying one of the layers of the elephant woman figure, probably a coating of old paint. She uses a method called Fourier transform infrared spectroscopy to analyze the organic substances in the coat. A beam of infrared light makes the molecules in the sample vibrate. A computer analyzes the spectrum of the absorbed light to identify the unknown substances and determines what compounds were painted onto the elephant woman over 50 years ago.
So what did you find out about the object?
We found nitrocellulose. Look, when I do a search, I get nitrocellulose. The results are clear.
We first try to find out the factors responsible for aging. How much light can a dye withstand before it fades? How much variation in humidity and temperature cycles can a material stand before it fractures? Is a museum really a better place to store objects than other places?
The imposing market gate of Miletus is one of the largest objects on display in a museum anywhere in the world. It fulfills all the criteria demanded by modern restorers. The repairs are clearly visible, and most importantly, they can be removed if necessary.
One criterion is very important: reversibility. A change or addition has to be carried out as much as possible in such a way that at some later point, when we have better materials, better methods or better approaches, it can be reversed and replaced by something new.
Once the results are back, Torolf Gopsch can get to work. He's stirred up a filler compound made of boiled straw, powdered loam, tiny glass beads, and cellulose paste. It will adhere to the nitrocellulose coating added in the past, and conservators in the future will be able to remove it easily.
This old putty that's left on here will function as a barrier layer, and behind it is the original material. I'm basically using the old putty bonded to a polymer as a barrier.
Conservators face problems with contemporary art. For example, Jonathan Meza uses toilet paper rolls and underpants in his work. Preserving biodegradable materials is a challenge.
Art academies certainly are still teaching how to make a painting keep for centuries. But more and more people are ignoring that. They're using lots of material, such as chocolate or wax, fruit and vegetables and so on, that are not meant for perpetuity. And that's going to pose a huge challenge to conservators and restorers.
Museums also house more and more objects made of polymers, such as plastics. Little is known about how these modern materials will age and how they can best be preserved.
The adhesives used by the ancient Egyptians were protein-based, simple binding materials that kept for centuries. We just don't have experience with modern polymers. And the probability is very high that they're going to pose huge challenges after just a few decades. That's why I think it's fair to say that we are not equipped to preserve the artworks of the 20th century.
The antique objects stand in their cases like trophies. They represent the victory of the restorer's art over the ravages of time. The Elephant Woman is also fit for the future.
I'm finally done, and I hope the figure will be around for the next 1,000 years.
It's hard to say how much future generations will see of the ephemeral artworks of our day, but it's likely that this ancient figure will outlive them.
In terms of evolution, thousands of years can be like the blink of an eye. Next week, we'll be taking a closer look at the subject when we travel to the Leipzig Zoo for a special edition of Tomorrow Today. 150 years ago, Charles Darwin published his funny little theory called evolution. This year is also the 200th anniversary of his birth. To mark the occasion, we'll be introducing you to a group of German school kids in Spain. They're following in Darwin's footsteps, observing how fish have adapted to their environment. Hope to see you again then. For now, from all of us here in Berlin, thanks for watching and goodbye.